All right, so now what we need to do is take this formulation that we came up for the capital budgeting problem and put it in Excel. So I have 5 decision variables. So remember, in Excel, we use a column as the as each particular variable. So this is going to be A, B, C, D, and E. This is my output. This is where the decision variable, the results of the decision variables will be. These are the decision variables, right? And then I have objective function. And this was net present value in millions of dollars. So that was 23154. Well, I remember that? Probably not. 23154. Did I get it right? 23154. Woo! All right. Subject to constraints. We had year 1 budget, year 2 budget, year 3 budget, year 4 budget. All right, those were the first 4 constraints, the easier ones. It's going to be my left-hand side. It's going to be my right-hand side. I had for year 1, I had 12 million, 8 million, 8 million, 4 million, if I remember correctly. And so we're going to have to stay less than or equal to that budget. Nothing says we have to spend all of it, right? If we had to spend all of it, which might actually be the case in the real world, then we would have a strict equality, but we don't need that right now. Let's make this a little bit prettier. Center everything. All right, so now I need to go back to the here. We have 3, 0, 1, 10, 2. 3, 0, 1, 10, 2. 3, 0, 1, 10, 2. Perfect. All right, then we have 0, 5, 2, 4. 0, 5, 2, 4, 0. You could leave the zeros out, but I'm going to put them in just to be safe. Then I have 0, 1, 1, 2, 5. 0, 1, 1, 2, 5. And your 4 budget is 0, 0, 1. Sorry, 0, 0, 0, 2, 0, 1, I believe, right? C has 2, E has 1. Perfect. All right. Then we get to our policy restrictions. So policy 1, D and E mutually exclusive. D and E mutually, if I could type today, mutually exclusive. So that's 0, 0, 0, 1, 1, and that was less than or equal to 1. Less than or equal to 1. All right. And let's see what else we have. Policy 2 was no more than 4 total projects. So at most 4 projects. And again, this is the easiest one. We have each variable and add them all up, and they've got to be less than or equal to 4. Then policy 3, A and C must be undertaken together. So I have a positive 1 in the A and a negative 1 in the C, and it's equal to 0. All right. A and C together or not at all. So 1 there and a 0, a negative 1, 0, 0, and that was a strict equality of 0 on the right hand side, right? Yes. And then policy number 4, our final policy, D and B. D is dependent on B. So I got minus 1 in the B, positive 1 in the D, and it's less than or equal to 0. So D depends on B. So I have a 0, a negative 1, 0, positive 1, 0, and that's less than or equal to 1. No, sorry, 0. Make sure that's a 0 on that side. All right, and that was all of the constraints, the structural constraints. So we need to put in remember on the left-hand side, we need a formula. So we'll use our good friend sum product again. I will make absolute reference to the variables and then use the coefficients here and drag it down. And let's check one to make sure. Yes, still pointing to the variables. Yes, pointing to those. All right. And then here's our objective function value. I like to anchor these even though it's not necessary. All right. And make that one a blue also. So now we have everything set up. What we need to do now is to solve the problem. So if I go to Data, Solver, I am maximizing I2 by changing the variable cells, the things in blue, B2 through F2, subject to the constraints. And here I've got a bunch of less than or equal to's and equal to, and then a less than or equal to. So I need to, I would probably should have put that one on the bottom up above, but that's okay. These are all less than or equal to, so I can add all those at the same time. All right. Click add, and another one. This guy is equal to 0. Add, and our last one is this guy, G13, less than or equal to I13. Click OK. All right. And then make sure we have non-negativity, change it to simplex LP. And just for fun, I have not put in the restriction that we must have binary variables. So just for fun, let's solve it without it and see if we happen to get zeros or ones, right? See if we're lucky. So I'm going to go ahead and click solve. And up here we see no, we did not. So I'm going to say restore original values, click OK. All right. So let's solve it again. So how do I make sure that the variables are binary? So like we did on a regular integer program, we need to add a constraint. This time we're going to reference the variables themselves. And in the drop down in the middle, we pick bin, which stands for binary. Right? Click OK. And now we see that B2 through F2 must be binary. Right? I'm going to go in here and change the integer optimality to get up to 0 also. And click OK. And solve. And I'll say OK. So looking at this, what is our answer? It says we should undertake a total of 4 projects. We should do projects A, B, C, and E. That's what it's telling us to do, for a total net present value of $10 million. So do we meet all the constraints? Yes, we're way under budget for year 1, under budget by $1 million for each year 2 and 3, under budget by $1 million for year 4. D and E are mutually exclusive, so D is not being done, E is being done. So yes, we're doing that properly. At most 4 projects, we have 4 projects. A and C together or not at all. We're doing both A and C, so good. D depends on B. So D is a 0, B is a 1. We're doing B, but again, that did not force us to do D. It's just saying that we could possibly do D if B was started. So we started B, decided not to do D. Right? So then you might want to ask, well, why don't we do D? Well, if you look at project D, look what it is in the first year, $10 million in outlay. That would mean you could only do one other project, and that other project would either be, couldn't be D because we can't do those, right? Sorry, it couldn't be, it could be C, but we couldn't because we'd do C and A together, so it doesn't help us. Or E, but we can't do that because they're mutually exclusive. So if we were to pick D, that's the only thing we could do, right? All right, so that that's what we need to do to solve this thing. We created binary variables by pointing to the variables in the solver dialog and picking bin, from the middle drop down box, forcing those to be binary integer variables.